Where's the link to the clicker again? Isn't it in the syllabus? Like the website?
Can somebody help him in the chat for that? Okay, folks.
It's in the modules. It'll say, I think, quote unquote, you need Reef app.
Oh, got it. Thank you so much, bro.
You can just go to App Store or something like that, Play Store or App Store, and look for Reef app, REEF, and
I got
download.
it. I'm good to go.
Okay. So look at this question here. It's just for refreshment, or let's say refresher, I should say, rather than refreshment. So I haven't opened the poll, so you cannot poll yet. I'm trying to arrange some window here, but this is giving me some. Come on. Uh-oh. By the way, can you see Zoom window with the videos here? I think you don't see it, right? Or you do on the screen.
Yeah, I see you're moving your mouse on day 3, velocity as a slope.
Oh.
We don't see your Zoom pictures, but we can see ours.
Okay. Yeah, that's what I meant to ask. Good to know that. So I'm hoping if this sometimes your picture may show up, okay, you guys don't mind it, because this one I have to post in the YouTube and then link it to the Canvas. Okay. So it's gonna be on the YouTube, although I keep this like on the unlisted or something like that. It's gonna be on the YouTube. Okay, so keep that in mind. So sometimes face of one person or the another person rarely shows up in that kind of situation. Okay, so now I'm gonna open the poll. And you have a minute to answer this question. Thirty more seconds. Oh, 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay. So this class, there are 52 enrolled students, and in participation, I am getting 42, and I see participants, 44 participants. I see kind of 48. That includes me. Okay. So some of you are looks like not participating or not here. I don't know. Okay. I strongly suggest you participate on that extra credit and learn things to do well in this class. Okay, folks? Okay, so let's see what we got here. Yeah, just like I got for that. We had very similar question on the worksheet as well, right? So there were some confusion. So I finished grading through those worksheets you submitted on the Canvas that was due Saturday night. Okay, I did that. So you should be able to see your score. Uh, but here, so this is the kind of problem we are still getting it. Okay, and I want to, I wanted to talk about this. Okay, so that we don't keep on making this kind of mistake. So I'm hoping you have my attention now and ready to talk about it. So let's suppose I'm thinking A as the correct answer. Am I right or wrong, and why? Help me here.
I would say that A is wrong because it's you're supposed to take delta x, not x. So if you're taking the position x at 12 after 10 seconds, you'd be dividing 12 by 10, which is where you get the 1.2 meters per second. But that's not delta x. Delta x would be the final minus initial, which is 12 minus 4. So you get 8, and then you do 8 divided by 10, and you get the 0.8 meters per second, which is C.
Excellent. And towards the end, your sound was also excellent.
I'm sorry about that.
Yeah, no, it was excellent. At the beginning, it was kind of faded, hard to hear, but I think we heard him. All right, uh, or them. Okay. So why A is incorrect? If you chose A, what went wrong? Did you guys know that? Do you know that now? To find slope, you cannot just choose one point and divide that number by another one, this, okay? So for example, at 10, you cannot just look at, oh, at 10, it is 12. Let's divide 10 by 12, okay? We cannot do that, okay? That works only when this line is passing through the origin here. In that case, yes, answer would be same, although your method is not so good. Okay, answer would be same by coincidence. That is not the correct way of doing it. Okay, so when it is so, always you need to look at 2 points that are convenient. Okay, 2 points that are convenient. So for example, I can look at this 5 here. Oh, it's right there, and there is 8. So 5 and 8. So this is, let's say, my T1, this is my X1, right? And let's say this is my T2, and this is my X2. So I'm choosing this particular point because the line exactly passes through this intersection. If I had chosen this one, yeah, I would still be close, okay? So since this is a straight line, I can choose anywhere I like. For the straight line, slope gonna be same no matter where you choose it, okay? So you cannot just divide x1 by 5 or x2 by 5. Sorry, 10. You cannot. Rather, slope is, remember, rise over run, right? Slope is rise. Rise means change. Rise comes from change in vertical axis. So in this case, slope gonna be x2 minus x1. Remember, this is what we call delta x. This is what we call delta x. Okay? And then time, we look at the same interval here. So the corresponding time. So T2 is not 15, it's 10, and T1 is 5. Or maybe I could have just written T2 and T1 as a formula for now, right? Like a formula. And then now I can plug in those numbers. So 12 minus 8, x2 is 12, that's 8, and then 10 minus 5, okay? So this is very important concept, folks. So when you do that, you get C as the correct answer. Okay, but if you just divide one by another one, x1 means 8 by 5 or 12 by 10, then you may get different numbers. Okay, that's not correct. So why slope are important? Depending on what you are doing, slope has its meaning. Slope of position versus time graph means velocity. So when you are looking for speed, even the speed from the graph, you should be looking at slope, not x over t. Okay, x does not give you correct distance. Okay, it does not. So you should be looking at slope again. So now, if it is a straight line, it's easy to get that, right? So let me give you credit for this one. So C was correct answer. So I gave you credit. Maybe it is outside the window, you cannot see it, but I already did it. Your clicker, your app should show up. Okay, so now here is another thing. We had two lines, one line going like this, another line going like this. So now I have this line here. Okay, I'm drawing separately. So when we don't have a straight line, then we need to think in terms of slope, how slope is changing, not how line is going. Okay, we don't follow the path, we think in terms of slope. So how do we think in terms of slope? So for example, let's say, what is slope at this point? P. So how do I draw slope at any point in a curve? So slope is also called tangent line. You may be familiar with tangent line, but if you are not familiar, let me show you how. And pay 100% attention here, okay? 100%, not even 1% down, okay? So let's say I want to know what's the slope at point P. Right next to that, I want to put another point right next to that. Or you can imagine putting it, okay? But when you are learning, you want to put that points. So now once you have 2 points, you can draw only one line passing through that point. And that's going to be the slope line. So in this case, slope line going to look something like this. My drawing is not first class, but that's how it's going to look like. See, it's sloping. It's not exactly flat. It's sloping a little bit down. Do you see that? The way I have drawn, right? So if I were to draw somewhere here, let's say, go ahead, you draw and tell, is it sloping up, flat, or sloping down? Go ahead, you draw it. You make this curve, and I'm drawing at the bottom of the curve. Okay, that point, the next point, let's say Q, is there. So you go ahead, draw the curve like that, and draw a slope line, putting another point right next to it. So what is next means here? Next means towards the increasing time, let's say. Okay, if the time is 1, then we may want to look at 1.01 second or something like that, towards the increasing time, although there is no axis here. So now, can you, with your finger, can you show me which way did you draw that line? Move your fingers in front of camera. Okay, I don't see all fingers moving. So I see most of them are kind of moving horizontal, and of course there are a lot of videos that are not on. So even without video, I'm hoping you are moving your fingers, okay? Although I cannot see it, you are moving it, participating it, you are learning, okay? So now, what happens here is that, yes, most of you were right. So it becomes kind of horizontal. What is slope of that line? rise is 0 here means slope is 0. Slope of this one, it's kind of rise means it's kind of falling, right? It's sloping, it's not like increasing, rather decreasing. So slope is negative. Now let's do one more point here. What do you think? So without drawing it, can you show me with your fingers? Yeah, it's sloping up, isn't it? So that's what you need to do. So even without putting any point, drawing any line, you should be able to tell how the slope is going. So how can you be fluent on that? By doing practice. Okay, by doing practice. So for example, from here, right next to that, and I draw this. Yeah, my drawing is bad here. Okay, so something like this. So it's sloping up, means it has a positive slope. Slope is positive and large. Okay, so now let's suppose if this was position versus time graph, or maybe I should write position or x, position versus time. That means each of those slope means velocities at that point. Okay, so what is velocity at this point? Slightly negative. What is velocity at Q? 0. Things turning around. Okay, it's coming to the stop before it's the sloping upward. It's sloping upward before it starts sloping upward. So from right here, it's going to be sloping upward. By the time it has already sloped upward, means moving towards the positive direction, and the speed is high now. Okay, it's speeding up. So that means it is accelerating, and it is also accelerating here as well. It's slowing down. Slope is decreasing. Do you see that? Can you move your eyes along that line and see the slope is decreasing? Right? It's slowing down. It's moving in negative direction. So if this was, let's say, east, that means up to this point, it's moving west. And here, so slope negative, velocity negative, what does it mean? Positive means east, negative means west, opposite. Okay, so that's what it means. So that's how you need to connect. Most of you did it correctly. Congratulations. Okay, but quite a few of you made a mistake there. Okay, so I hope you guys learn this, and there are going to be questions like this in the midterm as well. Let me tell you that. Okay, right away, question is out. There are going to be questions like this in the midterm. Okay, you'll see curve like this, straight line like this, and you'll be asked to find velocity from there. Position, velocity, and the acceleration. You need to know how things work. Okay, so this is maybe a little bit hard to see it. Do you see my mouse here? There is this curve, right? And I have drawn several red lines. Do you see that? It's a thin, I copied from slide. Okay, so now I think it's better. You see these red lines? Those are the slope lines. What's happening? Slope positive but decreasing, and slope becomes 0 here, means it stops, and then slope becomes negative, means it turns around. So that's what it is telling us. Okay, slope is changing, velocity is changing. So another thing, some of you kind of found it difficult to differentiate between position versus time graph, velocity versus time graph, versus acceleration versus time graph. Okay, there was difficulty there differentiating that. So when you are asked to find, draw a velocity versus time graph, you still kind of drew position versus time graph. So when we say draw velocity versus time graph, you need to think in terms of the slope, not in terms of, you need to think in terms of the slope lines, not in terms of the original line. No? Yes. Right? So if I were to convert this into velocity versus time graph, how it's going to look like? At the beginning, slope is positive, right? And large. Let's say, just I'm throwing a number here. Let's say this is 0.6. Okay. So that means velocity here is positive and largest possible for that. And let's say over here, the slope is 0.4. See, it's becoming a bit smaller, isn't it? But it's still positive. It's still slanting upward, means positive. So that means I'm assuming up as positive. And remember, this positive and negative depends on the assumption, okay? And so it can be positive or negative. So anyway, so that's positive. So 0.4 gonna be, so that point is there. So another time, what happens? We have the point is there. And over here, maybe even smaller, 0.2. So it's coming down. You see that? As time increases, it's coming down. The values are coming down. When it reaches there, what is the value of slope? 0. Yes, I like that signal. So that means velocity 0 means here, right? That's when this is 0, 0, right? So now, when it turns around, how does the velocity graph gonna look like? See, the slope becomes negative, means velocity, we have to go down in the velocity axis, but time is still increasing. So it's gonna look like this. Let's say this is negative 0.2. So that means it's gonna be something like this. See that? If I were to, keep coming down here, then it's gonna be sloping. Oh, my slope line looks a bit terrible here. So this is gonna be like, let's say 0.4 or 0.6, right? Something like that. So this is gonna go more negative downward. So now those are the points. Graph means we draw a trend line. See how the position versus time graph is curving, but velocity versus time graph is straight. You see that? Okay, so now let's say I want acceleration graph. Oh, by the way, let's go back to velocity graph first. So what's happening? As long as I'm in this part of the graph, and let's say this is up, that means I'm still up, moving in up direction. I'm still moving in up direction, but I'm slowing down. So what does that mean? Let's say, in this case, let's say up is this way, right? So what's happening? At beginning, I'm moving faster, and then slowing down is still in same direction, positive, see? Means same direction, but slowing down. Now I stopped. Do you see that 0 line here? I stopped. That's what that means. Now I'm going negative, means now I need to turn around, and then now increasing the speed. Okay, the value of v is increasing as the slope is increasing here. Okay, so and that's how it works. Okay, yeah, it may look strange until you pay attention and actually practice and draw a couple of curves and draw yourself. Okay, so now acceleration. So this is velocity versus time graph, and it's easier to see acceleration from velocity versus time graph. Why? Because acceleration is change in velocity over time. So that means is the rise. This is run for this graph, not that graph. The rise over run of that graph was velocity. Now rise over run for this graph is acceleration. So this being a straight line, what's happening? Is slope changing? Right? So acceleration is rise over run means slope. Is slope of this line changing?
No.
No matter where you draw that slope line, you're gonna get the same line. It's a straight line, okay? If it's not carving, slope is not changing, right? So let me draw a couple of lines here. So there is this line, sloping up, positive slope, but fixed value, slope is not changing, fixed slope. And if this is velocity versus time graph, acceleration is constant. Slope constant means acceleration is constant. How do I draw acceleration time graph here? So in this case, see, the slope gonna be positive slope, right? So that means acceleration is positive. And if this side is positive, then my graph gonna look like this. And time never stop. Time keeps on changing. I saw many of you just put a dot when it said it was constant. You did not draw a line. But it's gonna be line. Why? Even when it's not moving? Because we are plotting time. Object may not be moving, clock is still running, right? So what happens is, so even things not moving, what happens is you get line. So you don't get to just put a dot here, rather you need to draw a line, okay? If the acceleration was zero, the line would be here, okay? Now, if this line was sloping down like this, let's say, assuming up positive, then how would the acceleration graph going to look like? So sloping down means slope is negative, means your acceleration would be negative over there, okay? So, and that's what happens. And here that means it is speeding up at constant rate. It is slowing down at constant rate. And once it passes here, it turns around,
Can I
right?
ask a question really quick?
Yeah.
Just so I make sure I have this. So if the velocity is at a constant rate, like how we have it depicted in the graph, that means the accelerate like 0.6, 0.4, 0, then negative 0.2, negative 0.4. It's accelerating, decelerating at a constant rate. So that's how you get that straight line. Because no matter what, if it's moving, like I think of it as a car, if you're going in reverse or forward, you're still accelerating just in the opposite direction.
Right.
way.
Right. You
Okay,
got it
cool.
100%, my friend.
Okay, thank you.
Okay. And I like to avoid deceleration, the word. We just call, like positive acceleration, negative acceleration, right? So I like to avoid that word deceleration, okay? So now you can see this is like this one here, okay? So what's happening here? Acceleration is negative throughout. Slope is negative, means acceleration is negative throughout, means, oops, where is my pen? Okay. Flat line. It looks a little bit sloped the way I drew it. I did not mean to draw it like that, okay? Flat, parallel to the t-axis. So that's how it works, folks. These different kind of graphs. So when you are asked to find velocity graph or draw a velocity graph from position versus time or position time information, think in terms of slope of that line, okay? Rate of change. And this change thingy, it's not in physics, everywhere. How the velocity with which the money is changing, they call in, let's say, in economics, for example. No matter where you go, you see graphs, and they try to look at the trend based on the graph. So what do they look? They try to follow the trend, and they also try to look at how the trend is changing, at what rate. That's the rate of change, right? Probably you may have heard like the number of infected people due to COVID, it goes exponentially. Trend is exponential. Slope is increasing at large rate. That's what that means. Okay, and so yes, that's how it works, folks. So now what I like to do is I'm gonna go to the slide and bring couple of questions for you to make sure you learned things. Okay. Where is the graph I'm looking for? Okay, so here is a graph. Can you see this? So this is position versus time graph, and this is velocity versus time graph. To get graph, you need to get several velocities. To get several velocities, you need to think slopes at several places. Think about slope at this point here, slope at that point there, slope at that point there, slope at that point there, slope at that point there. And imagine plotting those slope, value of slope, 0 or positive or negative, larger, smaller. Think about plotting that, okay, to answer this question. Okay, so how long do you think you need? How much time?
2 minutes.
What?
2 minutes.
2 minutes. I see 1 minute. Let's go with 2 minutes. It doesn't hurt. But make sure you guys draw these and then draw the slope lines and so on, okay? So counter is up. So in my paper, this is what I will do. If I were you, and then try drawing those slopes, a lot of slopes, lines, okay? Is everybody drawing? Check with yourself to make sure you are drawing. 30 more seconds. Five more seconds. 5, 3, 4, 3, 2, 1, and it stops. I'm kind of forgetting countdown even from 5. This is not a easy question. It is not so easy question, okay? Although we just recently talked about it, it is not so easy question. And I don't know how you have done. So would you like to talk about this first, or you want to look at the result?
Can we talk about it first?
Result.
Want to talk about it first? Okay. So who want to go? So let's say I have this here. So for this, oops, what happened? For this, my slope line gonna be flat for this couple of points, right? So flat slope line means velocity is what?
0.
0. So that means the graph that does not start from 0 is not no-go, right? This means velocity is not 0 at time 0, right? At the beginning, velocity is not 0. That's what it means. So this is not good. So I can eliminate. Now 1, 2, 3, I have 3 of them that starts from 0, right? So now, if I go a little further, what's happening? Is slope increasing and becoming positive? Right? So that means velocity starts from 0 and then becomes positive, right? And from this point to that point, does it look like a straight line? Close to a straight line, isn't it? What does it mean? Velocity is
Constant.
constant. So this one says, okay, velocity increases and keeps increasing, right? But here it's based on the slope, it's not changing. So this cannot be, and actually this is just copy of that. So this is position versus time graph, and position and time graph, velocity and time graph cannot be same. Okay, so that's why this cannot be the answer. So now increases becomes constant, increases becomes constant. That's good. Both of them are possible. Now what happens here? It decreases and becomes 0 momentarily. Decreases and becomes 0 momentarily, right? Do you see that? Flat line. See, the lines are now sloping. Oh, I'm drawing too many of them. So over here, what happens? If I look at here, the slope line looks like this. If I go that point, slope line gonna look like this. Over here, slope line gonna look like this. So what does it mean? Slope is decreasing, and here it becomes 0 at highest point. That's the turning point. So that means velocity becomes 0, right? So decreases, over here it says slowly decreases, or like yeah, kind of decreases and becomes 0, decreases and becomes 0. Over here decreases and becomes 0. So after that, what's happening? Velocity is 0 in this graph, isn't it? After this point, velocity is 0 in this graph, isn't it? But the object does not stop in our case. What happens now? It starts sloping down. That means velocity is now increasing. Slope is increasing and it's negative. So that means velocity is going towards the negative one. Okay? And again, from here to here, it's a straight line, isn't it? So that means it's a constant. From here to here, it is constant. And here, slope is decreasing around this. And over here, line becomes flat, means slope line also going to be flat. Right? So that means it becomes 0. So that's why D is the correct answer in this case. So yes, a lot of thinking goes in there, drawing as well. It's not an easy question. Okay? If you did not get it right, don't feel bad. But if you got it right, celebrate. Okay, many of you got it right. Time to celebrate. But yes, we were wrong as well. Okay, so D is the correct answer in this case. So you need to think in terms of how slope is changing, and unless you get used to it, it is difficult task. Let me tell you that. So when we are at the graph, let me find another graph. This should be a little bit better than the other one. but it's still not so easy, but this is a lot better, okay? So this is velocity versus time graph, and this is acceleration. These are the acceleration, right? So how do you find acceleration from velocity versus time graph? What should you be looking at? Slope. Slope. Did you say slope? Although you did not say it loud, did you say slope in your mind silently? If you did, then that's good, okay? So now, let me open this. And for this, I'm giving you a minute, okay? A lot of straight lines, so you don't need to draw so many slope lines. Maybe we need minute and 30 seconds, okay? Minute and 30 seconds for you guys. Thirty more seconds. Five more seconds. 5, 4, 3, 2, 1, and it stops. Here I like to see the result, okay? It was just about following the slope, right? It is just like the previous question. Let's see. Hey, again, we are getting D, most of them, but of course, we are also getting A, B, C as well. So can somebody explain how, oh, too bad. I did not mean to start the poll, okay? I'll delete that one later. So can somebody explain how do we go about it?
You can kind of split it up into kind of 4 sections. So at the very beginning, you can see that it is going up at, so the slope is positive and constant. So that already takes out B and C because they start at 0, but that's not what's happening. And then you have that second segment that's just flat, which means the slope is 0. And so, and then you have that third segment, which is negative and constant. So you know it's going to be a negative acceleration value. And then the last segment is again flat, so it's 0. And the only graph that matches those 4 segments exactly is D. Because even though A looks like it should be correct, it doesn't have that second portion that is 0 slope. It just goes straight down into a negative slope. Yeah.
That was the excellent explanation. I couldn't have done better than that.
I have a question on that real quick.
Yeah, go ahead.
So I guess I'm just confused from the last graph. So when velocity starts at 0, right, with D, with acceleration versus time, the line doesn't start at the origin. I'm confused on, I guess, like when something starts on 0, how that looks like with acceleration. You know what I mean?
Anna, do you want to answer that question?
Yeah, sure. So the thing is that it doesn't really matter whether or not the graph starts at 0. It's just the instantaneous acceleration, right? So the acceleration at that specific point in time. So in this graph from 0, it's heading up, right? Like it doesn't curve upwards. It doesn't like change velocity. It's just constant,
Okay. And
right? You
that,
can see it's a straight line.
so then D, when that initial constant line, that indicates that acceleration is moving forward at a constant pace.
Yeah, yes.
So up to this point, it's a constant slope, right?
Yeah.
Positive and constant slope. So this segment is denoted by this positive acceleration and constant, whatever it is. You name it. Let's say, let's give that a number 10. Okay. So all the way up to here is a 10. So when you started looking at it, it was already accelerating. Okay. It was already accelerating. Velocity was increasing. Okay. So that's what it means. You can start from 0 velocity and accelerate. What does it mean in terms of, let's say, driving a car? Once you, let's say your car is not moving, you put foot in your gas pedal. What happens? Velocity increases, right? It goes from 0 to high value, 1, 2. See, it's increasing at constant rate. If it's going 0, 1, 2, 3, 4, it's increasing, right? So that's what it's happening. You pushing the gas pedal, it's accelerating, and it reaches to top speed, means it's not accelerating anymore. You are going at top speed, whatever it is, 60 miles per hour, let's say, up to this point. And now you see a traffic ahead, you need to stop. So you put, let's say, brake. What happens? Velocity decreases. But so car is still moving forward. See, velocity is still positive. Velocity is still positive means car is still moving forward, but it's slowing down. So when it's slowing down, that means acceleration is in opposite direction. Did we learn that? Yeah, we talked about that,
Yeah,
right?
I got that. The only question that I have too is then for C, that sharp line going up, that would indicate not a constant velocity. That would just be like like a continuous sharp, I don't know what I'm trying to say. See, like that first little peak, that just means that acceleration isn't constant, like it's continuing to rise, versus D is just that straight line is just saying it's
Right.
constantly
So
accelerating.
acceleration is increasing. That's what it means. Okay.
Okay. I
Right.
got you. Thank you.
Right. Yeah. You betcha.
Wait, so if the acceleration was like increasing exponentially, then it would be like the triangle shaped one, like it would be rising at that rate instead of being flat.
So acceleration could increase, like with any kind of behavior, like it may go like this, it may go like this, or it may increase like that. Things can increase anyway, right? So that means it is increasing either at constant rate. The increase rate is constant here. I'm not saying acceleration is constant. See the difference there? Rate of increase of acceleration is constant here.
Okay.
Okay, but here that's not so constant. Okay, so that's the difference. And over here, once it reaches to peak, it says suddenly acceleration becomes 0. Okay,
Mm-hmm.
so that's what happening here, no acceleration. And then now you hit the gas pedal suddenly, just a little bit, push just for an instant there, right? And then what happens? Yeah, up to this point you are pushing your not the gas pedal, sorry, brake. So what happens? Now it's not accelerating. Oh, you did not push the gas pedal here. Sorry, the brake. You just left the gas pedal. You let go the gas pedal. It's not accelerating, okay?
Mm-hmm.
Rather, what's happening is now it's moving at constant velocity here. Acceleration 0 means constant velocity. So, yeah, so that's how we need to think. So again, it's not very easy when you are just, like practicing those. So that's why I have these several questions. Okay. So now we learn about the graphs. How about change in velocity? Do you guys still remember this slide? Right? How do you draw change in velocity, right? You draw tail to tail, and then from tip of previous means in this case v1, previous to later, so that's how you get change. So what's happening here is it's slowing down. b2 is smaller than b1 means slowing down. Slowing down means acceleration or change in velocity is in opposite direction. We learned this, right? So just for a practice, let's look at this question here. So in this case, what's happening? It's going up and then suddenly turns around and it starts coming back. So b1 is previous, always 1 to 1 is previous than 2 and so on. Okay, so that's how I use the notation, and question tells you that. Okay, so now can you draw tail to tail and tell which way is the change in velocity? And change in velocity means acceleration, remember, right? So that means you are finding direction of acceleration. So out of these four, which one is it? So please go ahead, draw an answer. So 2 minutes for you. So do you have these two lines drawn? I can go to previous slide so that you can look at these steps if needed. Okay, here, those are the steps. And those two lines on the question looks like this. B1, B2. So in 30 seconds, I'll move to another slide so that you can choose A, B, C, D. For now, just draw looking at these steps, okay? And try to keep those steps in your head. We're gonna be using a lot. So I'm gonna be moving in the question slide now, okay? Here, so that you can choose your answer. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay. So can somebody explain how to draw it? So you tell me and I'll draw, okay?
So, someone go ahead.
Yeah. Go ahead, Peter.
So I didn't see E as a choice. I was kind of confused, but so you take the later, right? Which is, or I mean, you can draw either one. So V1, V2. What I did is I flipped them over so I could see better. And then when you draw any line, I think this is how.
Tell me which one I should draw.
So draw V1.
V1.
And then.
Now tell me what should I do to the B2.
So V2, you can, the way I did it, I think this is right, is line it up right next to it, right?
Where should I draw B2 from? Where should I start from?
Oh, the tip or the tail to the tip, right?
Before I draw that first step, we haven't finished the first step. we need to first line draw tail to tail, right?
Yeah, tail to tail.
So
Oh, I know what you're saying. So
B1
yeah,
has this tail over there, B2 has tail over there, so I need to move tail of B2 over there and draw.
okay. Yeah, I did not do that.
So that's first step, drawing tail to tail by lining them up, right? So I
Okay.
line them up, I drew tail to tail. So what's the next step, Peter?
Well, I'm not sure that I did this. I just kind of
Doesn't matter, we make mistakes. Just tell
Okay.
me, what should I do next? What's the second step?
so
From which? Tip
change.
of which?
So it's later minus previous, right?
Right.
So I mean, I just looked at it and thought, okay, accelerations are canceling here. So I don't know. Pass for me.
You mean velocities are canceling?
Or velocities are canceling. Sorry.
Okay. Okay. So let's see who's gonna help me next. So how should I draw? So this is first step. This is step one.
Don't you draw from the tip of the previous to the tip of later now?
So which one is previous?
V1.
B1. So tip of B1 is there. So to make it clear, I will start from here, right? And tip of B2. So that is my change in velocity. So don't judge without drawing it. It's very important, okay? So does that sounds correct, folks? From tip of first previous to the tip of later. So it looks like it's down. See, it was going up, it was going up, it started coming down, flipped, right? Reversed. So there is acceleration, and acceleration is downward. So that's why it's coming down. Acceleration is, backward. So that's why it's reversing. Otherwise, there is no point of reversing, is it? So it makes sense. So velocity reversing means acceleration is in that reverse direction. Otherwise, there is no point of reversing. That makes sense. And looks like C is the correct answer. Now I'm excited to see how did we do, everybody. Are you guys ready? 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 Uh-oh. Yeah, C is there, but quite a few E. So that E thingy, why does that happen? Because we try to draw in our head rather than drawing on the paper, okay? E thingy happens because we try to draw that in our head. Hey, one is going up, another going down, canceling, 0, 0, 0, 0, 0. That's how our head talks. But when you start drawing on the paper, it doesn't go like that, right? Right, 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 right. So I'm leaving this, okay? Or maybe I can do this. So let's say, oh, rather than leaving, let's go here, this slide. So now, rather than giving you drawn arrows, what is given is you are given the numbers and the direction so that you can draw arrows on your own. So can you draw 2 arrows for this speed and this direction makes it velocity? Previous or initial, okay? So east and west. So you need to put a compass in your paper. Okay, which way you want to say east. Make sure to put that compass in your paper before you draw those arrows. can you type on the chat which side did you choose your east? Up, down, left, right? And you can choose any direction you like. There is nothing wrong with that, okay? So another person chose right does not mean you have to choose right. To choose, you are free to choose, okay? You have a freedom of choosing that. Once you choose it. You stick with that, okay? So draw one, for example. Let's say if you chose east as a right, then maybe I can write this as an initial. Let's use this notation BI. You don't have to, you can use B1 if you like, but just for a little change, that's a BI. And this means east. But if you chose left as the east, then your BI gonna look like this. And there is nothing wrong with that. And if you chose up as a left, then your drawing gonna look like this. This is gonna be your BI. Down one, you think about it, right? So you can choose any direction. So now BI, and this, let's see, this BI is 12 meter per second, right? So that's just the value, and it's pointing this way or this way or this way. You can choose any way you like, okay? So now, what is the 16? That's gonna be the 16. BF gonna be 16 meter per second. Opposite. If you chose this as a BI, then your BF gonna be that way. Your BF gonna be that way. So it depends how you choose it, right? Right. So does it look similar to what we just did? In the previous question? Was going up, coming down, right? Here is going sideways, let's say, or up and down. It depends on how you choose it. The same idea. Velocity is reversing, isn't it? So which direction do you expect the acceleration to be then?
West.
West. That's right. So now, how do you find the value? See, you want acceleration, right? So to find acceleration, you need what? Oh, it's already there. Change in velocity, that comes from this drawing. And these arrows, they have length. See, this one has 12. So for example, if you stick 12 here, and if you were to draw like this, 16, then this whole thing gonna be 28. If you draw other way around, so how much is gonna depend on your drawing. So if you draw something like this, it's gonna be different, right? So if you draw like this and like this, and if you go something like this, so this length you can find based on these lengths. So I'll let you work on that, okay? Oh, it's already break time as well. So we'll pull this after we come back from the break. So it's 5 in my clock, 1:05. So we're gonna be pulling on this at 1, let's say 11, because you need a bit time to work on that after the break. We'll start, oh, we will start pulling at 10 and gonna close a little later. Okay, I forgot to record it after we took the break. Okay. So this is -16 is final because we are choosing, oh, sorry, that's final, and it's negative because it's west and we are choosing east as a positive, okay? So now let's do this math. -16 meters per second. This negative, when you multiply with the positive, what happens? It's negative, right? So now what are you getting here? Both negative means it gets added. It becomes -28 meters per second. Now what is acceleration then? It's delta V over delta T means -28 meters per second divided by time interval, which is 4. That is -7 meters per second. Now, see, our question doesn't have negative or positive. Rather, what we have, east or west. So based on our choice, what does negative means? It's a west. Okay, so that's how we do it. Hey, Carl, you wanted to talk, right? So go ahead.
Yeah, just real quick. Thank you so much, Dr. Nugana. I just want to remind everyone, just keep in mind, if you're having trouble right now, there's a lot of resources out there to help you. Dr. Nugana, obviously, with his office hours, but don't forget about SI. Now, remember, SI, different from tutoring, okay? SI is there to prevent the struggle. Now, it will help you if you're struggling. Don't misunderstand me, but please, it's there to prevent the struggle. Okay, so and tutoring is more to go there and ask these direct questions, maybe about your homework or something like this. So all the services provide something different, but please come to SI. It's a little bit different than like what you'd expect from tutoring, and it's going to help prevent the struggle. So if you're having trouble right now, come to SI, and I promise when you leave, you'll feel a lot better about things in terms of the information. And there's a lot of students from the class already coming. Some of them may speak up later on in the weeks, but they're enjoying it. Everyone that's came to SI in the past week said that this is just the most awesome thing, and I love it. Helps me so much. So make sure that you're coming, and if you have any questions, just send me an email. Thank you so much, Dr. Nugana.
Thank you, Carl. And if you guys wanna practice this again, what you can do is choose west as a positive and do it and see if you get the same answer. Okay. So your sign's gonna flip, but the final answer should be same. Physics does not change based on which side you choose as a positive or negative. Okay, so that's for you to work after the class. Now, do you guys can you guys tell, have you seen this kind of motion where velocity is going in one direction and it changes in another direction? Any examples of those? I hear free fall and question mark. So what do you think? Is free fall an example of that? I have this ball here, so I can throw this up. Yes, of course, there isn't much room here. Let me go back a little bit and see if I can do this. It goes up and then reverses back, right? Goes up, slowing down, and then reverses back, right? So this is one example. That's the free fall motion. Let's talk about that when we are still fresh in our mind about this one, right? So for that, what I have is this software and this video a little bit, and so this software is called Tracker software. Tracker, okay. It is very nice software. I like it, but you don't have to play with this. So there is this video where I have already done the tracking. What it does is it tracks the position of that object in certain time interval. So it's like a drawing motion diagram. So for example, do you guys notice there is this ball right here right now? And do you see this one number one popping up there next to it? It's yellow, so it's kind of hard to see it. So that's the first frame, let's say. One first, in your position motion diagram, that's one dot, right? And then next dot is there. See, this is going up, right? So I think 0 dot was here, 1 dot is here, and this is dot number 2. Okay, 0, 1, 2. Ball is going up, but as it goes higher, what happens? It slows down, isn't it? So what do you see? It's on the same time interval. Okay, it's in the same time interval. Gap is decreasing, means what? Slowing down, right? So what is the direction of acceleration? Going up, slowing down. What's the direction of acceleration? I see something coming on the chat.
Down.
Down, okay. So it's going up, but the acceleration is down. So how do we know? Slowing down. That's how we know it, okay? So if you were to draw two, like let's say vector, one previous and the later going to be shorter than the previous one, isn't it? And if you were to draw a change, it's going to be pointing down, okay? And there is a worksheet I have posted that has a question where you're going to be drawing those vectors while ball is coming down, going up, and so on, okay? So next frame, next frame, next frame. It's slowing down. You see that? Right? So now what I'm going to do is this software also makes the plot. So for example, this is position versus time. So Y, see, it is sloping down. So that isn't that what the slowing down means, right? Sloping down. So let me actually bring this one in here, make it bigger. Okay. So what do you see? There are two plots for now. So what do you see? There are these plots of the position. Okay. So what I'm going to do is I'm going to do this analyze. Maybe measure. Okay. And it lets me measure the slope. Do you guys still remember how we talked about how do we draw the slope line? Right? So it's going to draw a slope line for me. Do you see that? See, that's the slope line at that point. And what's happening? Slope is decreasing. You see that? Slowing down means slope is decreasing. Here it's becoming almost flat. Now it cannot find the slope for the last one because it needs two dots to find the change. Slope comes from the change. To find change, to next point, it needs another data. Okay. So this table here, those are the changes in velocity, so that basically gives you the slope, okay, at those corresponding points. Okay, see, those are the slopes. So now, this one here, now let me plot the velocities. Okay, let me plot the velocities. So velocity becomes, see, at the beginning when we throw it, velocity is higher. You can see the slope value here. Here it pops up over here, near here, okay, when I put the cursor. So look, keep your eye over here, near here as well. So you see that it says slope is 8.84. See that? So that's the velocity there. Over there, velocity is now 7.85. And we are plotting those here. Okay, so that's That's the corresponding velocity here. So velocity decreasing, okay? Velocity is decreasing here. So we are plotting that. And it was still going up. It hasn't started coming down, right? It hasn't started coming down. So that's why it hasn't gone towards the negative line. It hasn't crossed the horizontal line, okay? Although it says y are those points, okay? And these dots are for the velocities. Do you see that? So this becomes a straight line. So that means velocity is constant. Sorry, the acceleration is constant. So that's when this analyze thing comes in. So this is curve fit, right? So what happened? I did curve fit. Oh, I deselected the curve fit. So now let me select back to the curve fit, and it's fitting this velocity lines, okay? And what happens? It's a straight line. So time is like a x-axis, horizontal line is time, right? So multiple of time is a, that is the slope, okay? And what do you find? Let's see. Yeah, a times t, right? So slope is negative 9 point something. So it's saying the slope is negative 9. What does it saying? It is saying the acceleration is around 9 and down. 9 meter per second square and down. That's what it is saying. Okay. So so there is air. So because of that, we don't get like 9.8. It's slightly slower than 9.8. So, but that's what it is. It's a free fall acceleration, and I'm measuring that free fall acceleration using this tracking thingy. Okay, so that's what I'm doing here. So this ball is near the higher points. So now what I'm gonna do is I'm gonna track only the situation when it's turning around. When it's turning around. So let me now move to the another frame, just like I did. Okay. Do you see now there is a different color, kind of cyan kind of color, right? It was yellow, now it's cyan. So I'm now tracking near where it's reversing, okay? So now it starts coming down. You see that? It starts coming down. So even when it's coming down, see, this is velocity plot. When it's coming down, you see the acceleration is negative and constant. Acceleration is negative and constant. And let's see what's value. See if we can get that. Okay. So where is my fit thingy? Car fit. Oh, what happened to the number? Okay. You see that? This is still 9.2. Negative 9.2. So even when it's turning around, acceleration is fixed. Acceleration is not zero. Do you see that? That is very important. We may think, okay, velocity is zero there. So acceleration also is zero. But remember, acceleration is not velocity divided by time. It's the change in velocity divided by time. So even when it's flipping, change is there. Okay, so for change, we need either just previous or just next. So that gives you change, and the acceleration is not zero. Okay, so now it's coming. Now another one, I'm putting another color, kind of red. So it's when it's coming down, okay? So now, see those kind of traces back. You see that? The red, oh, the yellow kind of hiding now. You see that? So now, it's, the gap is increasing. Gap is increasing means acceleration is in the same direction. Velocity increasing means acceleration is same direction. So when it's coming down, acceleration is still down. And actually this tracker lets me plot the direction of acceleration. Now the arrow you see, they are pointing down, means acceleration is downward. If I were to go back and choose the yellow points, oh, where are those? And let's get rid of that. Okay, I'm not getting many yellow points, but looks like here you see kind of, see, even at the highest point, it says A. Do you see that A? That's the acceleration. Even at the highest point, there is acceleration in pointing down. Okay. So acceleration is never zero. And this is very important concept. We usually think, okay, acceleration is zero there. Okay. Okay. So even when it's coming down, the graph looks kind of something like this. Now what's happening? Slope is increasing, but it's negative. Slope is are negative here, right? Slope are negative. So that means velocity is down. That's what it means, right? And it is speeding up means the acceleration is also down. So now you see these accelerations, they are pointing down, and the length of the arrow, they are about the same. That means it's a constant, okay? So if I were to remove that arrows and plot velocity arrows, you see these arrows are increasing. That means velocity is increasing. That's like a motion diagram. You see that? On the top, it flips, just like we talked about the scooter example, okay? So the ball does the same thing. So a scooter was going horizontally, it's just going vertically, and that's what's happening. So acceleration is always downward. That's what we see it here. Okay. Anybody likes to add anything here? So let me get rid of all those. Let me play. So the ball is going up and coming down. And do you see the graph here? It traces the position while going up and down. So let me replay that. So look at the position of the ball while coming down. So this graph is for coming down, okay? So look at that and see how the position of ball, you see that's it's tracing right there, live view. And we can do that for going up as well, of course. So this is the graph now, right? For going up. Okay. So now I'm going to replay this video. You see, oh, maybe frame by frame looks better. So here right now ball is near the hand, lowest point. So graph is here at the lowest height. So this guy is about, I don't know, best. So my 0, 0 origin is here. So this hand is around 4.5 meter above the 0, 0 thingy here, ground, okay? So now what happens next? So ball is here, the graph point is there, and so on. You see that? You see that? You see that? That's for going up there. So that's how the graph of the position versus time graph looks like. And we can also see velocity versus time graph. And this is the velocity versus time graph. See that? It's sloping down, means acceleration is downward. So anyway, we talked about this. Okay. So now, the similar thing is here in my slide. So you see that this is going up, right? And this is motion diagram, well, going up. So you should be able to find change, draw a change in velocity by using any two of these, right? And for the highest point, you can use going up and coming down, this one next to each other, okay? Or if you just look at this and that, it's going to be just one, right? So that's that. So now we can make graph just like we saw. So this starts from here, the hand, when it leaves the hand, right? We start tracking from there. So next gonna be there, and next gonna be there, next gonna be there. Time is increasing and gap is decreasing, so that's why the graph is sloping like that. You see that? So that's my animation, just like it looks like a tracker. So now it reached the highest point and coming down here, okay? And now it's, so this kind of shape is called parabola. So this is position. And now once we look at the slope, so now can you gauge the slope? So here, larger slope, largest slope here. So if I were to plot that in this graph here, velocity time graph, what's gonna happen? That point gonna be, so we can use these lines, which we already talked about. We can use those lines, value of the line, and make this graph, okay? So at highest point, oh, by the way, if we look at this, what do we find slope? 9.8, and it's sloping down. And why it's negative? Because we are choosing up as a positive. If we were to choose down as a positive, then this number would also be positive. Keep that in mind, okay? So that highest point is here when it crosses the line. Yeah, it's kind of near the, bottom of the zoom window, right? So that's that. So we saw that in real, for that ball, it was around 9.2. But if we were to eliminate the air resistance, what's going to happen? You get number something like 9.8. Okay, so that's what happens. So one of the problem in the worksheet is directly related something like this. Okay. So here, so why we are not getting 9.8 for the ball? Because there is air produces drag. So for example, this brick is falling faster rate than the feather here. But if we were to do same thing on the moon, this is how it's going to look like. Unfortunately, at that time, it is, there wasn't HD video or something like that. It was broadcasted live from the moon. Solar wind and penetrometer drum in the ETD.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. Oh, I'll watch this. I have a good picture there. I've got beautiful picture, Dave. Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. And the feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
So it's the air that makes it, like come slower. Otherwise, if we can eliminate air, and moon has really thin air, so because of that, they are falling side by side. Okay. So whether it's heavier object or lighter object, they fall with the same rate, and their acceleration is around 9.8. Okay, for the Earth's surface. But for the moon, it's going to be different. So now, even here on the Earth's surface, if we don't use feather, but use lighter and heavier object like this, so watermelon is definitely a lot heavier than cantaloupe, right? So this guy is dropping this, and see if they hit the ground at the same time. Both hit at the same time, right? So, so yes, so that's the free fall. So what's the acceleration for the free fall, folks? Constant, right? Whether it's going up or down, doesn't matter. Acceleration is always downward and constant. So now here is this question related to, kind of free fall, isn't it? Bullet is going up and then coming down. So what do you think the acceleration is going to look like? Okay, let's verify that we understood. Okay, so you have a minute. So acceleration versus time plot for the free fall we are looking for. Okay. Not velocity versus time, not position versus time, but acceleration versus time. So it says assume up as a positive. So 1 minute. Thirty more seconds. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay. Let's see what we got. Oh, we got varieties of answer. Okay. Yeah, this grafting could be, still tricky. Hey, for C and D, we got exactly same. So what did we learn about the free fall? Acceleration is constant, not changing, remains same value all the time, and it is downward. Do you guys remember that? Right? So now how does that translate into graph? Not changing, not going higher, not going lower, remains wherever it is, and it is downward means what? We are assuming up positive means downward must be negative, right? So the acceleration is negative when we choose up as a positive, right? So this is constant acceleration, but it is zero acceleration. But object in free fall goes through the acceleration. They have non-zero acceleration, so that's why A is not correct. B, constant acceleration, yes. Flat line, not changing. Rate of change is zero, means constant, right? But here acceleration is on the positive side. Up is positive, okay? Here. So that's why B is not a good answer here. If we had chosen down as a positive, then this would have been the correct answer. Constant positive acceleration, okay? Now C, constant and negative acceleration. So that's why it makes sense. That is the correct answer. D, acceleration higher and then acceleration is decreasing. This is not acceleration graph. This is velocity graph you saw. It was velocity graph, not the acceleration graph, okay? So you guys still remember that, but you forgot whether it was velocity or acceleration. So that was the velocity graph, okay? So this is position graph. This would be the position graph, okay? So yes, so that's why C is the correct answer. So for the free fall, acceleration is always down and constant, never zero. That's what we learn by doing those tracker thingy and tracking, keeping track of, position and so on. So that's what happened, okay? And positive and negative, it simply depends on which way we choose positive. So what's the acceleration of free fall? You want to say 9.8 downward. 9.8 downward. So yes, while doing problem, you need to translate that into positive or negative. So for that, you're going to be choosing one side as a positive. So if you choose up as a positive, then acceleration is negative. If you choose down as a positive, and since the acceleration is also downward, in that choice, Acceleration is positive. Okay, so acceleration can be positive or negative depending on your choice of positive and negative. But what is always true is that acceleration is always downward. That is true. So the next class we'll look at the problem of the free falls, and then we're going to look at the not just going up and down, rather going sideways as well, projectile. Okay, we're going to look at the projectile as well. So for the projectile, you want to read that from the book before you do the pre-lab thingy. Okay, there may be some better question as well. So keep that in mind, not pre-lab, but the pre-class thingy. Okay, so we already over the time, so I guess we need to leave it.
I have a quick question, 2 questions.
Yeah.
For the book, for when we're supposed to look in the book, are there assigned page numbers or just look through the book and see when it says projectile or whatever? Because I read something through the book when like I looked at the handout and then looked at the book for this free fall, but I didn't see assigned page numbers.
Oh, you want page number, huh?
I'm just wondering. I'm totally fine looking through it. I was just curious if I'm missing something.
Yeah, I haven't provided page number. There might be section on the syllabus, but what I will always do is I'll bookmark this book, right, and go to the table of contents, and chapter number is definitely there in the syllabus. Okay, so falling objects, and now for the projectile, it's over there in third
Cool.
chapter.
And then my other question I had was, what can you, I forgot who the gentleman's name was. Can you repeat the SI times?
Carl, are you still there?
Yeah. I'm here, and I will also. I forgot to mention this because I didn't want to waste class time, but I'll send out a reminder before every SI session. They're gonna be every day. Today, your SI session is from 7 to 8:30. So Tuesdays and Thursdays, it's